So far, we've learned how to simplify radical expressions. We've learned how to multiply radical expressions. Now we want to know what to do when we are dividing radical expressions. So just like with multiplying, we have this nice property. So with multiplying, we can separate as long as the two things are being multiplied under a radical. We can also separate if two things are being divided underneath the same radical. This mainly is just important to understand because we need to know that these two forms mean the same thing. We're not necessarily going to be switching forms the way we did with multiplying, but it's very important to recognize that these mean the same thing. And specifically, if they're under the same, we can separate them because we're going to be learning how eventually to do something called rationalize the denominator, and it involves, if you have something like this, separating it out. This is really, really important because, like I said, we're going to be rationalizing a denominator eventually. And when we do, it is extremely important that if we have a common factor in both the numerator and denominator, we reduce first. It makes the work so much easier if we reduce first if we can. Also, a good thing to know is you can only reduce if all factors are either under a radical or not under a radical. For example, 2 over 4 can be reduced to 1/2. The square root of 2 over 4, nothing can be done with that because one of them is under a radical and one's not. But the square root of 2 over the square root of 4 can be reduced to be 1 over the square root of 2. You'll see some more of that in these examples. I'll kind of try to keep pointing out when we have common factors or when we don't, and when they're in matching form and when they're not. So I want to look at a total of 3 examples. For each of the examples, we're going to simplify as much as we can. So remember that we're always going to reduce first. So if I look at my first example, I have the square root of 12x to the 4th over 3x. Well, I know that both 12 and 3 can be divided by 3, and x to the 4th divided by x. So I'm going to take a break for a second and show you where this is coming from. I'm going to give you a rule similar to the way I did with multiplying. So if you remember from the last video, when we multiply, and I'm going to put it up here because I have a little space up here, when we multiply a to the m times a to the m, multiplying same base gives me a to the m plus n. I add my exponents. And if you remember, we looked at that example of x cubed times x to the 5th where we expanded it out. Give me x times 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 x, which is why, or where we saw we added them. Looking at division now, I'm going to go ahead and say what happens when I have x to the 4th divided by x. Well, it's x to the 4th over x is x times x times x times x divided by x. One of my x's cancel, leaving me with x cubed. Well, wasn't the exponent here 1 even though we didn't write it? So what do I do when I have same bases and I'm dividing? Well, when I'm multiplying and I have same bases, I added. When I'm dividing and I have same bases, notice that 4 minus 1 is 3. So the rule is a to the m over a to the n is a to the m minus n. So you're going to see me using that over and over again in here. Okay, so now that I've established that, coming back over here to my problem, I know that 12 and 3 can both be divided by 3, leaving me with a 4 on top and a 1 on the bottom. X to the 4th divided by x, I know that would be 4 minus 1, leaving me with x to the 3rd on top. My x down here would cancel out to be 1, leaving me with the square root of 3, dividing by 3. So the square root of 4x cubed all over the square root of 1. Well, isn't the square root of 1 just 1? And do I really need to write it if it's just a 1 on the bottom? I don't, right? So that's the same thing as just saying 4x cubed. But I was asked to simplify as much as possible, and we've had now a lot of exposure to simplifying these types of problems. So I'm going to go ahead. I'll do this one by grouping, and then I'll do the next one with fractions, and then the final one with grouping. Go ahead and say this is the same thing as the square root of 4 times the square root of x cubed. I know that the square root of 4 is just 2. If I think about x cubed, that gives me x times x times x. So if I have 3 x's, I can make one group of 2, making a group of 2 because this is a square. Therefore, my index is technically 2 even though it's not written. So one group of 2 with 1 left over, and there is my simplified version, my final answer. Looking at the next 2 examples, it works the same way if you have a cube root as opposed to a square root. So remember I said that you could not simplify unless they were both common, so either both under a radical or both not under a radical. Here's what I meant by this. This 6 and 4, I can reduce them because those are both not under a radical. This expression here and this expression here, I can reduce those together because they both are under a radical. So looking at the 6 and the 4, I see those can both be reduced by 2, giving me a 3 and a 2. I see that 45 and 5 can both be divided by 5, so I'll be left with a 9 on top and the bottom will be gone. I see that x to the 6th and x can both be reduced by 1x, so leaving me with x to the 5th on top, and that is gone on the bottom because, again, I subtract 6 minus 1. I see that y cubed divided by y cubed. Well, a lot of times I see people want to say y, but look at what happens when I have y cubed divided by y cubed. Don't they all cancel out, leaving me with no y's? So the y's are just gone. So again, on the bottom, I would have the cube root of 1. Well, what number multiplies by itself 3 times? Isn't 1 times 1 times 1, 1? Well, then the cube root of 1 is just going to be 1, and 2 times 1 on the bottom is going to leave me with just 2 on the bottom. I have to simplify the top, so I'll use exponents this time. So the 3 stays. If I think about my perfect cubes, like 8, 9 can't be divided by 8. 27, 9 can't be divided by 27. So I see 9 doesn't have any perfect cubes, so I leave it under the root. That's going to become x to the 5 over 3 because my index determines my denominator, which is then going to simplify to be 3 times the cube root of 9. 3 goes into 5 one whole time with 2 left over, all over 2. Well, x to the 2 over 3, this, if I want to change it back to radical form, my numerator stays as the exponent. My denominator becomes the index on my radical, giving me 3 times the cube root of 9 times x times the cube root of x squared all over 2, which means my final answer, putting it over here because I'm running out of room, is going to be 3x times the cube root of 9x squared all over 2. And there's my final answer. Looking at one more problem, my third example, just like it worked with cubes and with square roots, it's also going to work the same way with fourth roots. So first thing I do is I see 8 out here. 8 and 32, yes, they do have a common factor of 8. However, because the 8 is not under a radical and the 32 is, it does not matter. They cannot simplify together. The only thing I could simplify 8 with would be if there was a number out front, which there is not, so the 8's going to stay. So I'm going to rewrite the 8. I can, however, simplify the 162 and the 32, and I know that they can both be divided by 2, giving me the 4th root of 81. I know x to the 15th over x to the 4th will reduce. 15 minus 4 is 11 to be x to the 11th. There is nothing to reduce the y with, so the y is just going to stay. So on the bottom, I'm left with, I reduced the 162 by 2, which means I also had to reduce the 32 by 2, leaving me with 16. Remember that when I reduced x to the 15th and x to the 4th, 4 x's canceled, leaving me with no x's on the bottom. From here, I always have to check to see if I'm in simplest form. Well, I did fractions on the last one, fractional exponents, so I'll do grouping on this one. So that leaves me with 8 times the 4th root of 81 times the 4th root of x to the 11th times the 4th root of y all over the 4th root of 16. Well, I know that 2 times 2 is 4, times 2 is 8, times 2 more is 16. So since if I multiply 2 by 2 4 times, I get 16, the 4th root of 16 is 2. Cleaning this up a little bit, I also know that because 3 times 3 times 3 times 3 is 81, the 4th root of 81 is 3, giving me 8 times 3. X to the 11th, how many groups of 4 can I make? Well, if I have 11, I can make 2 groups of 4, and I still have 3 x's left over. If I look at the 4th root of y, and I ask myself, if I have a y, how many groups of 4 can I make? I can't make any. So that y stays under the radical. I have a 2 on the bottom. I can go ahead and multiply the 8 times the 3. giving me 24x squared times the 4th root of x cubed y all over 2. Now, if you remember in the beginning, I looked at this 8 and said I couldn't reduce the 8 by anything because the only thing on the bottom was under a radical. But look at now, this 2 is no longer under a radical. And 24 and 2 can both be reduced by 2. So even though I couldn't reduce in the beginning, I have to go back and check in the end. So doing a final check in the end, I notice I can reduce top and bottom by 2, giving me 12x squared times the 4th root of x cubed y as my final answer in most reduced form.